Hello, and welcome to the Civil Engineering Tech Program's pre-recorded lectures. This one for structural mechanics dealing with determining the resultant using a graphical solution, or commonly referred to as the tip-to-tail method. Let's take a look at a scenario. If we have a point, an object, and we want to determine what the resultant force is on this by three forces acting on it. One force acting this way, pushing on it. A second force acting, pulling on it this way. And a third force pushing on it this way. We can graphically solve this. Now what we do, we make the length of the vector the magnitude. So if this was 400 pounds, I can make that 4 inches long, or 2 inches long, depending on what my scale is. But I'd have one thing. Let's go to another drawing. Let's draw this again. So I have an object, and let's say I have three forces act on it. A 400-pound force, a 200-pound force, and a 50-pound force. The 400-pound force is acting at an angle of 220 degrees. The 200 is acting at an angle of, say, 300 degrees, and the 50 is acting at an angle of 20 degrees. So what I do, I graphically can draw these on a scale. I'm going to say 1 inch equals 200 feet. So if that's my scale, the lengths of my lines are going to be 2 inches, 1 inch, and 0.25 inches long when I graphically draw this. I'll draw this right on my object. So my first one is 2 inches long at 220 degrees. So 2 inches long at 220. And then I have a second force that is 1 inch long acting at 300. So 1 inch long acting at 300. And then I have a third one that is 50.25 inches long, acting at 20 degrees. So there's my three forces acting on my body at their respective angles. Now, what I can do to determine the resultant, what is the resultant of these forces? I'll set a point, and we do what's called the tip-to-tail method. So I'm going to take the first force, which was the 2 inch, this one right here, and I draw it right at that point, at that length, which would be 2 inches long, at that angle. Then I take the second force, and from the tip of that first force, I'll place the tail of the second, boom, and I'll draw that 1 inch long at 300 degrees. So at this point right here, then this force is acting at 300 degrees from the tip, or this was acting at 200 degrees across to here. And then we'll take the third force down and put it to the tip, and we draw that at 0.25 at an angle of 20 degrees. And the resultant then can be graphically drawn from the starting point right here to the tip of the last force. That's my resultant. Not only that, but this is my magnitude. So I can graphically scale off the magnitude. And I also can calculate at this point now the angle. So I can get both properties, both the magnitude and the direction, from using the graphical tip-to-tail method. Once again, let's look at it. So if I have a body and I have, say, a variety of different forces acting on it, one coming this way, and I graphically scale them so their magnitudes are correct. And then I have a second force acting on the body right here, going this way. I have the third force acting on the body right here. And let's say I have a fourth force acting this way on the body. So I have 4 of these forces acting on the body. Now we're not accounting for moments right now. This is just the resultant vector of the forces. So we start off with a point. And we start with the first point. We bring it over and graphically draw it at the correct angle. We take the second point, tip to tail. The third point, and the fourth point, and then graphically our solution is going to produce a resultant that has that magnitude having this bearing. In the sense, what we found is if we have these 4 forces acting on this body, their net effect, as you can see, they're pulling this way, they're pulling this way, and they're pulling this way. Their net effect, by the time they start canceling each other out, is going to be one force acting this way on the body of that magnitude. So those 4 forces are all pulling on each other, canceling each other out, and the net result is a small force at that angle pushing that direction. And that, in a sense, is how to graphically determine the resultant using the tip-to-tail method, with the major understanding that you have to graphically draw these correctly. The magnitudes have to be drawn exactly along with the correct orientation, the correct angle. The more sloppy you are at drawing your exactness in terms of magnitudes and angles, the more error that will be introduced into your resultant graphically. But this is how the tip-to-tail, the graphical method to determine the resultant is figured. Thank you.